All right, final exam, again, is, thank you, Katrina, 15th from 1 to 3 p.m. And you find that by, I'm going to just do a Google search, Temple final exam schedule, boom, right? This is the final exam schedule that every class must adhere to. If your professors are not adhering to this, then they are wrong. And in which case you contact like somebody above their head if they were the like. Because now mind you, there is some confusion because, you know, technically you registered for 4 hours, but our meeting time is for 3-hour courses. That's because we have 3 lecture hours and 1 lab hour. That's why that happens. So as you can see, we meet from 2 to 3:20 Tuesday to Thursday. This is the only time listed that meets from 2 to 3:20, 2 to 3:20 on Tuesday, Thursday. So our exam is Tuesday from 12:15. So Tuesday, 12:15, 1 to 3 o'clock. Okay, that's when it is. Okay, let's see. Got another question in the chat. Give me 1 second to get everything out of the way. Okay. Oh, yeah. Section leader, that's just something I forgot to remove. I thought I got everything. I must have missed it. Okay. Okay. All right. Yeah, I can speak after class briefly. Okay. So I do have a meeting later today, but that's later. But anyway, let's go ahead and talk about final exams and final grades, because I'm sure that's weighing heavily on everybody's minds. So first off, again, I believe that you can withdraw up to the up through the 7th. So if you're feeling unsure in any of your classes, you can do that. So let's close this, stop screen sharing for a second. All right, and again, let's just go to Canvas because that will be the most useful place for us to go. Share screen. Let's go and screen share on Canvas. I need to share my sound. What am I sharing? Screen share. The dashboard? Oh, yeah. Okay, so I was. All right. Over here, first off, breakdown of grades. If I look at my assignments, right, this should be listed for you somewhere else, but right, your solo exercises are worth 10% of the grade. Anything under active learning exercises is worth 30% of the grade. That includes tracks. Your quizzes were worth 30% of your grade overall. Final project is worth 20%, and the final exam is worth 10%. That should add up to, yeah, it adds up to 100. Just making sure. Okay. I will, for the projects over here, for these guys over here, here's what's going to happen. Any level 1 project, basically first step project, like, so we're talking Pong, Pokédex, or web or homepage, those are going to be out of 100. Whatever you submitted, you will get marked excused for the other 2. That is something I'm going to do, go through and mark manually on the 7th. Okay. For any of the other ones, they will be out of 0 points. Okay. And then I will go through and I'll fix it so that anybody who's demoed them will get 100 out of 0 points, which will mean you'll get 100 extra credit points tacked on top of it. You do have to demo those. Anything under active learning, you should demo. Be sure to finish the progress report tonight. To just, if you needed to make a last minute change to your project, that's where you need to let us know. So anyway, that's the weight of your grades. As you can see, doing the solo exercises and the homework are account for a pretty good portion of the grade, as does the final project. So let's go ahead and just talk about another question that I got asked about, which was how does a curve work and what do you have to get an A? In my syllabus, I am specific in some areas and deliberately vague in others. So let's just go ahead and talk about that. So specific in some areas, the area I'm specific in is, here we go, is letter grade. This is where I'm specific. Letter grades will be, and notice I had these things swapped around, the final project and the final exam, but I announced in an email that I swapped them, those weights. Letter grades will be assigned at no higher than an A is greater than or equal to a 90, B is greater than equal to an 80, etc. That means that basically that if you get 90, what I'm trying to say here is that the curve only helps. It never hurts someone. If your raw score is a 90 or above, you're getting an A. If your raw score is 80 or above, but less than an A, you're getting a B. If guaranteed. Okay. In general, you need like 70 to pass a 70 average to pass the class. So the way the curve works, generally speaking, is that I look at these, I go through and I look at, I sort your grades, your final grades from highest to lowest, and I don't look at the student. And I basically start looking at, your on your transcript, it only shows the letter grade. Okay. By the 7th, you can turn stuff in. Notes and 50 gram, one of them will give you 100 extra credit points. They're optional. Okay. So there are one. All right. So what I'll do is I sort the grades and I look basically for, and I start looking at the grades that are less than 90. I go, okay, 89.8. That should be an A, right? That's A, right? I'm going through that. And 80, so, and then I look, an 89.5 and so on and so forth. And maybe I'll see an 88.5. And then the next grade after that is an 87.5, which is a point gap, whereas I'd been seeing smaller point gaps between the two. Okay. So at that point, I'll probably cut off the A grades, so to speak, at around 88.5. So anybody who got between an 88.5 and a 90 will get an A minus. So I use minus grades to curve people up to the next level. That's how I apply grades. So does that make sense to everybody? So basically, right, and that's what it's been in the past. An 88.5, like anywhere like from 87, depending on semester, 87.5 or 88.5 have been A minuses. I'm going to run Runestone again on December 7th, most likely. And then the last day you can demo, the last day where we'll have specific times available to demo is on Monday. If you need a demo after that, it really just depends on your circumstances. So try to get all the homework is due on the 7th, last day. I cannot make anything due later than that. I cannot say like you haven't built past the 7th to turn it in, because official university policy is I can't say that, right, as a due date. So yeah, we just have a video for the final project. That final project is essentially your demo, because trying to schedule that would be madness. I can. On the 7th, what's going to happen is, by the way, I'm going to be, on the 7th, I will be going through and I will be adding, let's see. Let's go ahead and say quiz. I will at some point. But basically also on the 7th is when I would go through and anything not turned in or demoed, I'd turn into a 0. Okay, or so after that, if you demoed it, I would, of course, redo it. But after that point, the 7th, anything that's not been demoed or turned in, those will be 0s because is that. For rubric for the video, there's really not so much a rubric as that I gave you some instructions. So over here for the final project, I said it should be a walkthrough or slides or screenshots or voiceover or live action. Your video should somehow include your project, name, year, and any other details you want to convey to your viewer. We're interested in what challenges you encountered in coding and if you found a way to overcome them. Okay. So, but I want you to walk through, essentially. The guidelines are fairly loose this semester. I'm mainly interested in the challenges and seeing how well you performed under this self-guided process, which is very demanding for a freshman course. So again, this is a 1,000-level course, so I'm taking that into account. Plus it's COVID. And also it's the first time I'm doing this. So I'm really interested in seeing what you guys did. In general, this is how you get an A. But if you made an effort, well, if you made a walkthrough and it was 8 minutes more, then the things you wanted to cover in a walkthrough, I would create in a README file so that if you needed to give directions, you could create in a README file. You don't have to walk through your code. I want you to show off what your product is, essentially. So when in doubt, if you need to elaborate, create a README file. Okay. In fact, you should have a README file. That happens. I'm interested in seeing how far you managed to get and what that problem was. So specifically, Jenny, what kind of problem did you encounter? That's correct, Tina. Well, Tina, actually, what you do is you do the first problem in a track, and then the second problem is extra credit. GitHub is preferable, but you can submit it on Canvas too. I'm interested in seeing what you learned on your own. Yes, please. I will have time available during the finals week to demo stuff. Right? I'm really interested in, look, for those of you who did not complete your project, I'm more interested in the journey you had, not necessarily where you ended up. Yes. Yeah, you need to upload all your code that you did in this project. So that's the kind of bugs and stuff that would be that. If they are, if you have time to mention them, otherwise put it in in your README file. Let me go ahead and add that. Your video should be a general overview of the final product. If include else you want to say, such as the difficulties you faced or overcame the things you learned, what you enjoyed, you see in a README file. That's preferable. You upload everything. Yeah, you can explain that, or you can explain that in the README file. Difficulties you faced or overcame. Yes, definitely. If you used anything from another website, cite it. You cite it by making a comment. That's it. Computer science citations are a lot easier to do than other places because we assume that you're looking at something on a computer and therefore can hyperlink it. Okay, I don't need a bibliography. I just need citations. I need a comment with the URL. Okay. So the main thing is to say, I got this from somewhere else. It is not mine. I'm not plagiarizing this though, because I'm giving it credit. So, okay, so there we go. Save. Yeah, sure. Okay. What I'm trying to get across about the final project is don't panic if you weren't able to finish it. As long we can tell who made an honest effort to try to do something ambitious and failed, and we can tell who made an honest effort on something that they thought wasn't ambitious but turned out to be difficult, and just wasn't able to. And we can tell somebody didn't even try and they just tried to gobble some code together from online and throw it together into something that worked. We can tell. We really can. Cobble, not gobble. All right. Other questions about the final project? Let me put you more at ease. As long as you made an honest effort and show that you made an honest effort, you're going to pass the final project. Okay. So, other questions? Now, let's see, question. Will unfinished projects, if the unfinished state is really cool, it might be. Well, if you actually try, but it comes off as you did it at last minute, like your project wasn't the most complex. I mean, that's what the proposal was for. So, you know. Okay. So, all right. Now I figured that today I would help review for the final exam by doing something at least what passes for fun in computer science sometimes. One of the great joys of the holiday season as a computer scientist is a small little game called Advent of Code. It happens every year. Some guy makes these puzzles and releases one a day. And they're computer science puzzles. And they're pretty fun to do. So I figured I'd work through one of them in class to kind of just show you. They get progressively harder. You can look at previous ones, but basically the plot of it is every year you need to save Christmas somehow. So each day has two problems. One that leads into another. So I figured, and I haven't tried solving the first one yet. I looked at it and I thought, that's reasonable and understandable to the class. So let's do it. So I don't know what part 2 is yet, but I know what part 1 is. And it seemed pretty darn reasonable for this class. So I figured I'd do it because it does have some questions that parts of a question I would that are useful. File reading, string parsing, things that you definitely should practice. So let's look at problem 1. Okay, after saving Christmas for 5 years in a row now, you've decided to take a vacation at a nice resort on a tropical island. Surely Christmas will go on without you. The tropical island has its own currencies and entirely cash only. The gold coins used there have a picture of a little picture of a starfish. The locals just call them stars. None of the currency exchanges seem to have heard of them, but somehow you need 50 of these coins by the time you arrive so you can pay the deposit on your room. To save your vacation, you need to get all 50 stars by December 25th. Jake, that's fine. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle is 1 star. Before you leave, the elves in accounting just need you to fix up your expense report, your puzzle input. Apparently, something isn't quite adding up. Specifically, they need to find 2 entries that sum to 2020, and they need you to then multiply those numbers together. So, for example, suppose your expense report contained this. Okay. In this list, the 2 entries that sum to 2020 are 1721 and 2020. And 299. So adding them together, you get 2020. Okay. Right. See that from here? You add these together. You can take it on faith that they add up to 299 if you don't want to do the math too hard. Okay. Okay. Multiplying together produces this number. So the correct answer would be this one. Of course, your expense report is much larger. Find the 2 entries that sum to 2020. What do you get if you multiply them together? To begin, here's your puzzle input. And of course, it's a much bigger pile of numbers. So we need to figure out which of these guys adds to 2020. So let's go ahead and copy this and put it in a file for us. 200 numbers. So let's go ahead and throw it on our desktop. And I'm going to go ahead and I'm going to just call it input.expenses.txt. It doesn't really matter. And we can read through this in pretty much any language. Oh, and let me go ahead and share my entire screen so that you can actually see what it is that I just did. So all I did was create a file. Okay, and I dumped it into here, saved it on my desktop. Now let's go ahead and make a corresponding file called puzzle1.py. Okay. Okay, it's a bit of a corny thing, but honestly, it's a bit cheesy of a concept, but honestly, I think that's perfectly fine. Okay, so first thing we'd want to do is read this file. How do I do that? Right, we use the good old open command. We use the file name, expenses.txt, and we simply put it into a read-only, and we put it into read mode. And let's call this data. Okay. Now, here's the thing. Most problems, right? This may not be immediately obvious, but I've ran into this issue multiple times. So if you run into this problem multiple times, then it does kind of become obvious. I can't just go through this file once, right? I can't just go through it once because I could only then read one number at a time. And then how could I check all possible combinations, or rather all possible pairs, right? I have to check all possible pairs of numbers for this. So how do I do that? Well, going up and down a file really doesn't work. So instead, what we're going to do is that we're going to just read this line by line and put it into our own list of numbers. So let's create a new list called numbers. So, and then for line in data, what we're going to do is simply say numbers.append. and we're going to put it into, and we're going to do int line, right? Just simply turn that line into an integer. And let's go ahead and always test your code. Very important, right? Even though I was pretty sure it was going to work, it was very important that I tested that. Print numbers, boom. Okay, so we're on the right track here. Great. We've got this now. Now, what I have to do is I have to find a pair. So I need two numbers, X and Y, that when they add together, they get to 2020. Okay. So what I have to do is I have to go through let's let every number be X in turn. So each number is going to take a turn at being X. For that number, I need to see if there's another number in the list, let's call it Y, that if I add them together, it's 2020. So every number has to have a turn being X. For every number in numbers, what do I have to do? I need to see if there's another number in that list that where if I add it, it's going to be 2020. So that actually means I have to do a nested loop on the same list. So let's see if I can just do this. And yes, there will be a case where X and Y is the same number. Numbers. If X plus Y equals 2020. Oh, did it update? Yes, I'm using Cascadia now. Okay, if X and Y is 2020, and now I got it. So I installed my font. Let's go ahead and add ligatures. Font ligatures, true. Whatever. It's fine. Can live without my, oh, no, it does use ligatures. Great. Just that's. Okay, so if the two numbers added together is equal to 2020, what are we going to do? We are going to just simply print out X and Y at this point because yep. And there we go. We've got two numbers. So it makes sense that we would get it twice. The first time would be for when we first found the number, and the second time would be when we found the first time would be when we found the first number, and the second time would be when we found the second number and checked it against all the other numbers, right? Does this make sense? Where I just basically am checking every number against each other, including itself. It's a nested loop for each number, for every other number. Check it. So if that's the case, then I'm going to actually store them here as A. And let's go ahead. In that case, we'll just simply print. This should be, let's go ahead and print X times Y, which would be the answer we need for submission. So which is 299, 299. So let's go over here and check and see what we got. You are right. Awesome. You are one gold star closer to saving your vacation. Part 2. The elves in accounting are thankful for your help. One of them even offers you a starfish coin they had left over from a fast vacation. They offer you a second one if you can find 3 numbers in your expense report that meet the same criteria. Using the above example again, this guy, if you add together using this example again, adding 3 numbers together gives us 2020. That'd be 979, 366, and 675. Multiplying them together gives us this answer. So now we're doing the same thing, but for 3 numbers, which for us in Python really doesn't make too much of a challenge. I don't think. Except for the fact that now that we are nested 3 deep, which means we are going to have to do 200 to the 200 to the 200th power checks. So we'll see if my computer is just going to scream at me or not. because for the record, right, if we're checking 200 numbers against 200 other numbers, it would be 200 squared. So here we're doing 200 cubed. What was I talking about? 200 to the 200 to the 200. Here we're doing 200 cubed. So yeah, totally possible. So here we just modify this to do it for 3 numbers and run it. And it makes sense now that we would get, how many did we get? Like 9? No, 6. 6, because we've got the first time once for each of the combinations of numbers or permutations of numbers. So let's go ahead and submit our answer. That's the right answer. Excellent. So as you can see, it starts lighting up whatever he's drawing over here. So, all right. Do people want me to take a look at the next problem? Because these are kind of fun problems. Your flight departs in a few days from a coastal airport. The easiest way to get down to the coast from here is via toboggan, which is a simple sled used by children, also a traditional form of transport used by the Innu and Cree of northern Canada. Here's a child carrying a modern style toboggan. Also a bum slider, I guess. So anyway, the shopkeeper at the North Pole toboggan rental shop is having a bad day. Something's wrong with our computers. We can't log in. You ask if you can take a look. Their password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed by the official toboggan corporate policy that was in effect when they were chosen. To debug this problem, they have created a list, your puzzle input, of passwords according to the corrupted database and the corporate policy when the password was set. So for example, suppose you have this following list: 1 to 3A, space, ABCDE. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. So for example, 1 to 3 means a letter the password must contain A at least 1 time and at most 3 times. Okay. In the above example, 2 passwords are valid. The middle password, CDEFG, is invalid because it has no B's, but it needs at least 1 B. So this is saying the following password needs between 1 and 3 A's. It has it. Needs 1 and 3 B's. It doesn't. Needs between 2 and 9 C's. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it had 10 C's, I assume it would be invalid. How many passwords are valid according to their policies? Here's our input. Obviously, now again, one of the things about computer science is all these things are solvable by hand. It would just take freaking forever to do it. And our goal is to be able to learn how to do it quicker on a computer, so that, or to program the solution quicker on a computer. So let's go ahead and create a new file called, they gave us 1,000 these time. Whoops, it gave us 1,000 these time. So passwords.txt. And let's create a new puzzle2.py. Normally, I don't let my desktop get this messy. I'm probably going to yeet everything into a recycling bin after I put it in the right place. Love that word for some reason, yeet. Don't know why. Okay, so we've got all our passwords, and they're always in the following format. You've got numbers, then a space, then a number, and this. So unlike this one, we don't have to iterate through the file multiple times. We can solve this as we iterate through the puzzle. But this is definitely one of those annoying string parsing issues, right? So we've got 3 fields. Basically the input, the numbers, the ranges, the letter that we're going to be looking for, and the password. That's always what it is. And then got, and all those things are split by a space. There's an annoying colon at the end over here that we can just toss. There's no problem. Okay. So here's what we're going to do. We are going to start by sanitizing our input. So first things we're going to do, we are going to say data is equal to open sesame passwords.txt read. Okay. And now what we're going to do is that we are going to look at each of these lines and kind of just make them easier to handle. Because that's the first thing when I see a problem that's complicated like this, I want to get the data into the discrete parts that I can easily handle. So for line in data, what am I going to do? I'm going to simply say, first thing I want to do is line.split. First, let's just see what line.split on space will give us, just to kind of confirm that reality matches up with my mental model. So it does give this, gives me this, this, and then I've got the new line at the end, right? So that's exactly what we want. So I'm going to call this parts is equal to, parts is equal to line.split, and it splits it into 3 parts for us, right? So now we can take each of the parts in turn. The first part has 2 parts really, which is it has a upper field. So let's go ahead and say we've got our range. Sorry. Let's call it bounds because range is a special word. Bounds is equal to the first part, which we will digest a bit more. Let's call it bound. Letter is equal to part. We'll clean it up a bit actually after we do that. And then password is parts 3. And now if we print bound letter password, you'll see that we still kind of need a bit more of a, it needs a bit more work to help it. Here we go. All right, we've got our numbers. So that colon so let's go ahead and start with the easiest thing to deal with. We've got a colon here. We don't need that colon. Dot. So there's 2 ways to do this, right? We can just simply say, hey, letter should be equal to we only want the first letter of that. It's a letter, so we only want the first thing in there. So get index 0 from that. And you see now that successfully removes it. In fact, I could shorten this by putting it over here, right? Of this part, get me the first thing in the index, but that looks awful and hard to read. Another thing we can do is we can use the string commands instead if you're more comfortable than that. There's many ways to cut this apple, so to speak, which is strip. And and this would just simply remove any kind of leading and trailing colons from it. So same kind of deal there. That's great. Okay, next, let's also go with the password. It had that weird hanging new line after that. So I'm just going to strip that as well, just to clean it up, make sure there's no extra spaces or tabs or whatever. Okay, now let's go to the bound. There's actually 2 numbers in there. There's the lower bound and the upper bound, right? Which are distinct parts. So, so we'll want to actually split that as well. Bound is equal to bound.split. So we want to split that up, and it's got a dash in the middle. So rather than splitting it on a space, I'll be very specific, and I'm going to say split on the dash instead. Makes sense. So again, this normally wouldn't take this long. I'm just trying to walk you through it and talk it out. Okay, so here we've got our split over here. And so now it's got two distinct parts. And now I can say upper is for our upper bound is equal to bound 0, and we're going to throw that into an int to turn it into an int. And then lower on, well, actually I have that reversed. So I'll just reverse these, right? Easy mistake to make. So upper, right, is this guy over here. Lower is the first one, the one at index 0, right? Small and big. That would have been very annoying otherwise. So what we need to do now is we need to basically, well, we can use the fact that we have strings in here and count these kind of things. Okay, so, and this is so much easier in Python, I gotta say, because of the way Python allows you to do numerical if state, greater than, less than comparisons. So if password dot count, right? The spacing is aesthetically pleasing to me. That's all. So if password dot count of the letter, and then this is where I love Python because I don't need a confusing and statement. If lower and boom, upper. Look at that. Isn't that nice and clean, right? Then good words is equal to 0. And that's just the number of good passwords. Good words plus equals 1. And we'll go ahead and print out that. And at the end, so that we have an answer to use, print good words. $456. So let's go ahead and see if our answer is correct, or did I mess up somewhere, which is entirely possible. Woohoo! Correct. All right. So let's see what the other part is. Because let's see what horrors this will bring. While it appears you have validated your passwords correctly, they don't seem to be what the official Toboggan corporate authentication system is expecting. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his old job at the sled rental place down the street. The official Toboggan corporate policy actually works a little differently. Each policy actually describes 2 positions in the password, where 1 means the first character, 2 means the second character, and so on. Be careful, Toboggan corporate policy has no concept of index 0. Exactly one of these positions must contain the official letter, must contain the given letter. Other occurrences of the letter are irrelevant for the purposes of enforcement policy. So given the same sample list from above, it's a bit easier when I think I know what they're getting at, but let's see what they are. So 1 to 3. So they're starting at index 1 here, by the way, index 1. They're throwing us a wrench and saying indices start at 1. This one is valid because positions 1 contains an A and position 3 does not. 1 to 3 is invalid because neither position 1 or position 3 contain a B. And this is invalid because both position 2 and both position 9 contain a C. Now, this logically may be confusing, but I see what's going on here. What they're using is something called an XOR or exclusive OR, often and that's spelled, by the way, for everybody in the chat, XOR, exclusive OR. So OR, right, is, so let's talk about OR for a second. OR is if one or both are true, then the entire clause is true, right? And is if both are true, then the entire clause is true. But if only one of them is true, XOR kind of flips it on its head, or XOR, depending on how you pronounce it. Okay, so for XOR, we say, hey, this is true if and only if one of the conditions is true. So if A is true and B is false, A is true, XOR B is false, then it's true. If A is false, XOR B is true, then it's true. But if A XOR B, if A is true, XOR B is true, and it's false, right? One or both. Exactly one of these positions must contain the given letter, it's saying. So there's a couple ways to do this. You could count. You don't have to use XOR. You could count the number of occurrences, right? But what it's caring about is does it have the required letter at that index? So completely different puzzle. So we still have our upper and lower bound. It's our if condition that really has got to change now, which is that instead what we're going to be doing is we want to say, and I'll do this a couple different ways, I guess. So first, if, let's go ahead and do occurrences. So let's do it without using XOR first. Occurrences equals, so first occurrences is equal to 0. If password lower, so that would be index 0. So if they gave me 1 as lower, I would want to subtract 1 so I could get index 0. So lower minus 1 equals the letter occurrences plus equals 1. And then we do the same thing for upper. And then we say if occurrences right, there's 3 outcomes here. There's no occurrences, 1 occurrence, or 2 occurrence. And what we want is exactly 1. So if occurrences equals 1, then that means good words plus equals 1. So that should solve it. And it would say 308. So I'm going to double check that one just to make sure I'm on the right path before I go and say, here's how we do. Yep. Okay. So how do we do the second one? Well, what's the other way of doing it? Well, the other way to do it is we could do the XOR statement that I had mentioned, the XOR, which is we could do if password go. If password is equal to letter,
like what?
Let's go ahead. If password is equal to letter, let's see. Do we have a XOR? Let's go ahead and look up how to do XOR in Python, because in Python, in other languages, it's this operator. So I just want to make sure. XOR Python. How do you get the logical XOR? Is it not built in? Yeah, let's try and see. In other languages, it's that caret symbol. And I think that's it for bitwise operators. Don't get me started on that. So we'll go ahead and try it. Otherwise, I know there's a we can do an annoying fix for it, but let's see what we get. Cannot XOR string and string. Oh, it wants it as an operator there. So, okay, so it thinks that we're doing it as an operator. So instead, what I'm going to do, and therefore it had a higher precedence. So let's go ahead and enforce order of operations there. And there. So that's the exclusive OR operator. So 308. Okay. I find little puzzles like this to be highly enjoyable. They are a good way because practicing is really the best way to get to that high level skill that basically we see or we imagine other people having. Another good site for these kind of things, by the way, is Project Euler. I assume that's my password. Okay. 59322. Yep. Now, Project Euler is one of my personal favorites because they have a lot of different problems and you can keep track of the ones you finished. And they're math problems that require you to do this, that require you to use computer science. So I want to kind of, for the last problem, I guess, I want to leave you with a kind of a deceptively simple concept called the Collat Sequence. It's a bit nerdy, but it's named after the guy who created it, Collats. Okay. The following iterative sequence is defined as the set of all positive integers. So the following sequence is n. If we're at number n, the next number in the sequence is n divided by 2 if n is even. So for example, if we're currently at 8, the next number would be 4. If we're at 4, the next number is 2. If we're at 2, the next number is 1. If we're at 10, the next number is 5. What do we do though if the number is odd? If the number is odd, the next number of the sequence is 3 times that number plus 1. So if we're at 5, then the next number in the sequence is 16, right? 5 multiplied by 3, 15 plus 1, 16. And then the next number would be 8, and then 4, and then 2, and then 1. Once we get to 1, we stop because then we'll get into an infinite loop where basically we start at 1 and then go 4. And we go to 1 to 4 to 2 to 1, 1 to 4 to 2 to 1, and get kind of old very quickly. Okay. Or as XKCD puts it, the Collats Conjecture. The Collats Conjecture states that if you pick a number, and if it's even divided by 2 and odd multiplied by 3 and add 1 and you repeat this procedure long enough, eventually your friends will stop calling to see if you want to hang out. And notice that he's got a graph here just showing that how numbers kind of lead to each other. 24 divide by 2 gets to 3. 3 times 3 is 9 plus 1 gives us 10. Divide by 2 to get to 5, right? Notice that 10 links to 5. And then I've already talked about the 5. 5 goes to 16, which divide by 2 until you get to 1, right? In fact, any chain in the powers of 2 gets you into this chain. You get this nice kind of graph. If we look on Wikipedia, Collats Conjecture. Now, this is actually an unsolved problem in mathematics. which is to say that there is that nobody has been able to, everybody believes that, but here's the question. Does the Collat sequence eventually reach 1 for all positive integer initial values? It's unsolved because nobody's been able to prove it yet. Paul Erdos said about the Collats Conjecture, mathematics may not be ready for such problems. He offered a $500 prize for its solution. It's an extraordinarily difficult problem, completely out of range of current mathematics, proving the sequence. And it's a very simple sequence, right? You can explain it to your parents. Here's that graph again, just rendered in a bit more of an easier on the eyes fashion. Okay. Why does 101? Why does 101 go to 19? That's not odd. Weird. Of small numbers. Oh, okay. Small numbers, so it gets bigger and eventually you'll get to 19 is what it's saying. So, and mind you, we've checked a lot of numbers. Experimental evidence. As of 2020, the conjecture has been checked by computer for all starting values up to 2 to the 68th power, which is pretty big. All values tested so far eventually end in the repeating cycle of 4, 2, 1. All right, so here's the project Euler problem, which I've solved before and always have trouble solving this, even though I've solved it many times. It can be seen that this sequence starting at 13 and finishing at 1 contains 10 terms. Although it's not been proven yet, it is thought that all starting numbers finish at 1. Which starting number under 1 million produces the longest chain? That is the question over here. And I have the answer, of course, over here, which I've solved before. But it was a tricky one to solve. So what you have to do is we have to, let's see. So what we're going to do is that if we want to solve that one, the easiest way to do it is to use a dictionary. Euler 14. And let's create a dictionary. And the dictionary is, it's going to be the number of steps. So 1, let's see. So let's go ahead. What is the length sequence of length 4? Okay, yeah, so it would include itself. So 1, if we start with 1, we just end with 1. If we start at 2, 2 divided by 2 goes to 1, right? So that means that that sequence is too long, right? And 4 would be 3 long. Make sense? I'm just kind of populating with initial values here. So, right, the sequence for, if I start with 1, is just, oh, I'm done. If I start at the number 2, it's going to go to this. 2 to 1, which is too long. And 4 is going to be 3 long. So how long is 3? 3 would go to 16. Sorry, would go to 10. To 5. To 16. Right. And then that would go to 8. 3 to 10 to 5 to 16 to 8, which would, and then once you get to 8, dividing by 2 would get to 4. But we've already solved 4, so we could just simply say 4 plus, so we could just simply say this plus the number of steps it took us to get to 4 is equal to our answer, so 8, rather than going through and recalculating that. Does that make sense? Well, we might need that as a time-saving mechanism later, depending on the speed of computers these days. So, so we're looking for all the Collat sequences from 1 to 1 million. So for n in range, or starting point in range of, well, we started a million, so we're going to, so we've already got 1 and 2. So we're going to go up to, he's up to a million. Under 1 million. So we can just simply slap in a million here. So all the numbers from 3 up to, not including million, we don't need to, you know, go ahead and remove that guy. You don't need the 3 there anymore. So n is equal to start. And what we're going to say is while n is not equal to 1, right? If n is even, so if n mod 2 equals 0, if it's even, then n is equal to n divided by 2, right? If n is even, then the next item in the step is half the number, right? Else, the next number in the step is n otherwise, the next number step is 3n plus 1. Okay? Makes sense? Right? That's the Collat sequence right here. If we're dealing with the even number, we have it. Otherwise, we multiply it by 3, add 1. Okay? Let's go ahead and do it over a smaller sample size. So what we're trying to do is we're trying to populate our keys here. So steps is equal to 0, or let's see, steps is equal to 1, steps plus equals. Because we start out with n as our first number, and then we would add another number each time we do an operation. And then when we're done, steps is our dictionary. Let's call it steps dictionary then. Steps dictionary is equal to the start value, for the starting value is equal to the number of steps at that point. And then we can store it and print the steps dictionary. And so it runs for the first 1,000. And let's check our first initial values. 3 has 8, which is what we predicted. 4, 5 has 6, 5, 16, 8, 4, 2, 1. So that's 6. So that seems to work for the first. So, okay. So now let's just go whole, full throttle. And I tried on a million. Computer's working on something, right? Right, Task Manager? Are you working on something? I guess, maybe. You know what we need to let's take a look at our processors. Yeah, we had some intense stuff. It took a while for this to run. It took a considerable amount of time for this to run. Why? Because it takes a while for this to calculate. Once we've got this, we got to find the biggest thing in here, which isn't as hard as it seems. But let's make this run a bit faster. Okay? Which is while n is not equal to 1 and n not in, because if we're in a number, if we hit a number that's in our steps dictionary, right? If we hit a number that in the chain that we already added, then all we need to do is simply say is do steps plus the steps to get to start is the number of steps it took to get to n plus however far n is from the end of the sequence. And if we do that, you'll find that it runs, I think, a bit faster. Yeah, that was considerably faster, right? So there, what I'm doing is I'm working on information that I've already tabulated, which is a pretty nice technique there. Part of the reason I did it in a dictionary too. Okay, now let's go ahead and find the largest item in this. For for starting point steps in steps dictionary dot items. How are you trying to give me a lookup error? Right? Best start is equal to 1. Most steps is equal to 1. If steps is greater than or equal to most steps. So if we are looking at each of the steps and we find, hey, this thing has more steps than what we've seen so far, then we've got a new best starting point. Best start is equal to start and most steps is equal to steps. Print best start, most steps. And so we run this. Actually, most of the time it took there is to print it out. It says that if we start at number 837,799, then the sequence will have 556 numbers in it. And if we check, that is the answer for this problem. So again, there's just all these kinds of just nice mathematical tricks that are very nice for Python. All right. So it is currently 3:07. So let me go ahead and reiterate what will be on the final exam. Okay. So what are the 3 things that are going to be on the final exam? The first question will be something similar to the regular expression question that I talked about during the regular expression lecture. If you were not there, watch those lectures. It's going to be, if you watch it, it's going to be fairly easy to do. Guarantee it. Right? Where basically what you're doing is you're opening a file and you're writing a file. And what you're doing is that you're taking information that's stored in one file and writing it to another file. You're basically creating a copy of a file only with some personal information redacted. It might be, in the example we worked on in class, we took all the social security numbers and simply censored them so that we couldn't see them. In the example you might for the exam, it might be social security numbers, it might be phone numbers, it might be driver license numbers, and I'll give you whatever the format is, right? I'll explain whatever the format is. It might be license plate numbers, it might be temple email addresses. Specifically, if I were doing that, it would be like TU letter at temple.edu that I'd be asking you. So it's going to be one of those that I'm going to give you a file. I'll give you an input file and expected output. Like, here's what an input file is. Here's what you should expect as output for your file, so you can download it to your computer and work it and test it, right? Because I want you to have as much control over that as you can. But again, if you check a look at that lecture, it took us, what, 7 lines to do if we used regular expressions cleverly, and we didn't really need super powerful regular expressions. We just needed the /Ds and the /Ws. We just had to remember to put the R in front of the string for raw strings, which we use in regex. Okay. The next question will be something that unfortunately you can't really prepare for because it's something completely new. And you're just gonna have to do that. There's 3 questions essentially, or three broad questions. I will also have each question has multiple parts, by the way. So I'm going to like say, okay, if you successfully opening the file, 5 points, successfully writing a file, this many points, right? So each part has, I'm going to try to make each question as modular as possible so you can score points by, so I can easily see, okay, this, so I can give you points for this. Okay, so each question will have the rubric attached to the question. Okay, second question will be something that you have not seen before. Or if you have seen it before, actually, I think we have mentioned it in class, and it will only be mentioned, if it was mentioned very briefly in passing. Okay. So but it's going to be something built into Python. It's not going to be like a made up mathematical operation or something like that. It is going to be something where if you did take like mathematical concepts or something, then you're going to be a bit of advantage for this one because you'll know exactly what it is. But we're going to basically be using this. I'm going to say, this is what it is. Here's the operations that it does, right? It's built into Python. So here's the documentation if you want to look on it. But here's my explanation, which because it's me, it's obviously superior. So but the Python, but basically here's the operations on how you work with it and what you want to do. And now here's a problem. Hint, hint, use this to make your life easier, right? So the problem will probably be something that you don't need to use you don't necessarily need to use this new thing for. You can probably make do with other stuff, but using this makes your life a lot easier. Okay. The third one will be a Monte Carlo approximation of a game that one of Blazer's games. So we're talking something with a 6-sided custom die, a custom 6-sided die. Remember I mentioned that in the last lecture that I uploaded. So remember, you're going to want to use random.choice for that to build the die. And basically what I'm going to ask is, hey, what are the chances? This is a cooperative game. Here's the die. Here's the rules. How often do the players win? Make sense? Again, the game is going to be very simple. We're not talking Dungeons and Dragons. We're not even talking out Fox. This is like a game made for 2-year-olds to teach them the concept of taking turns. And that's not to insult your intelligence, by the way. I'm just trying to say that, like, I don't think you can handle something more.
Do you need Laser to come over there and explain?
No, don't. I might attach a video of him explaining, but we could attach a video of him explaining if we wanted an alternate explanation. So we'll see. Yes, it's going to be very similar to the Monopoly example, but in some ways simpler. The rules are going to be simpler, but there's going to be a few more things you might have to keep track of, which are not necessarily, that doesn't necessarily make it hard. Okay. The game itself, again, is you'll understand when you see it. It's simple games can be interesting statistically to look at. Okay. So those are the 3 broad questions. And again, those questions are made up of multiple parts. It's one big question, but I will say, okay, like for the game, do one iteration of the game, right? Simulate the game this way is worth this many points. Simulate, yeah, similar to the pig assignment. It's similar. If you've done well in the pig assignment, then this all the Monte Carlo stuff that deals with die is going to be very similar to each other. Right. So simulate one run, and then maybe you would if you were to simulate it 1,000 times, then or however many, a statistically significant time, then that's worth a certain number of points. Being able to gather the data correctly is worth another amount of points. Displaying it is worth another amount of points, right? If you remember, for the problems on the exam, I will go ahead and show you again, right? Kind of what that looks like. So are you guys just binge watching Daniel Tiger over there?
Yes.
There's worse things in life. Okay, so teaching. So Maggie, it is not my intention that it takes the whole amount of time. However, it will take time because you're going to be students on the second to last day of finals who are exhausted and who are going to be second guessing yourself. So does that make sense? Right? It's not going to be necessarily strenuous for that reason, because my goal for this is that that the exam is concise. It would show me a accurate representation of your abilities without necessarily being too arduous. Right? Why subject you to a stressful torture session when I can ask 3 nice broad questions and see what you've got done? And again, normally I might make it longer, but this semester is not normal, nor so I should not treat it as such. I should not pretend that it is a normal semester. All right, so let me go ahead and yes, if your project still has issues, depending on the quality of the project, it can still be in the top 3. I'm going to be meeting with the TAs today to explain my parameters. Just wanted to show you, right? So a lot of files. So this is from an exam. I still want to use this question, so I don't want to necessarily show the entire question, but the entire question was a bigger question. And I say, here, write a program that calculates and prints the following. 5 points for giving me the hottest high temperature, 5 points for giving me the coldest low temperature, 10 points for calculating the average temperature of it. So I broke it down into multiple parts that were, digestible. Similarly for the Monopoly thing, right? I broke it down into multiple parts so that it was easy to get points for. Let's see if I've got the exam 3. Oh no, I put that on. All of us will be taking a look at the final projects. Your TAs will primarily be looking, and if they have questions, I'll be taking a look at it, and then I'll be giving my input as to what the best projects are. So it's a bit of a team effort there. Okay. Let's see. Just trying to find another rubric question, but if you want a practice question for all right, so this was designed for regular expressions, this practice exam, but let's go ahead and give you a practice question that you can refer to. Okay, so if you want to practice on regular expressions, create a regular expression that will identify all integers where the digits are in numerical order. Allow the empty string. So for an example, 0, 1, 4, 4, 5, 7, 8, 8, 9 should be would be matched by the regular expression, and 8, 9, 5, 3 would not be, because they're not in numerical order. The digits, they're not sorted. Here's another one. Make username. This one doesn't need regular expressions though. So again, you can refer back to this. I'll upload this as soon as the lecture is done. And then it does. Here's a practice though, one that is specific for that. I'll answer that question in a second. Here's a specific question for practicing for the final exam. Write a function given a file name, creates a new file with the exact same contents as the original file, but all the phone numbers, such as parentheses 123, close parentheses, space 456-7890, are replaced with the string private. So that is pretty much the format of the question you would see on the final. But I would give you a bit more direction on the final and a bit more explanation, as a bit more specificity about the formatting rules. Okay. So again, if you need that, you can refer to it. So should we demo the extra credit homework? Yes. Demo the extra credit. Okay. Now, as far as demos, right, everything needs to be turned in by the 7th. Okay. But after that, you can still demo to me and your TAs. If you can get them, I'll set up times for you to demo with me if you need to demo stuff. But work has to be turned into this. Yes, me and TAs will look at the final projects and for the favorites. So yes, even if you don't complete your best case scenario, you can still get an A. I'm interested in the journey, not the destination. If they're ties, then I guess, I don't know, we'll burn that bridge when we get to it. Is there still lab next Monday? Yes, there's still lab next Monday. So you can demo your labs and frantically work on last minute stuff if you need to. All right, it is 3:21. I want to say I am very proud of all of you who have kept up with this work. I know it's not been the easiest semester. I really do. And I want to say that I am impressed with the effort you have put in. For those of you who've continuously managed to put in effort this one, and for those of you who have not been able to put in effort, but basically, you know, life happened and stuff piled up and you're still making strides to try to get everything done. I'm still proud of you and still impressed by your effort. You know, I know the semester was tough for everybody. And I really appreciate you all putting up with me during these, you know, interesting times. Hopefully, starting next year, hopefully by fall next year, we'll all be able to be in the same place again. And by then, you'll probably be ready to take 2168, which is my next class that I teach. Professor Fiore teaches 1068. I think also Professor Lafayette teaches them. I think Professor Fiore is a great professor. He teaches the vast majority of the sections, and Professor Lafayette takes a bit to get to know, but I think he's great as well. I really likes Undertale, that guy, from what I understand. So, all right. So, and you're more than welcome to participate in the Discord channel even after class. So you don't have to quit if you don't want to. So, all right. So, the class is dismissed. Anybody who wants to stay behind and talk to me for something, then please